Good morning, students. Welcome to Brilliant Public School. The topic for today's discussion is linear programming problem for class 12th. Linear programming problem is defined as the branch of mathematics which deals with the optimization of linear function, which is in the form of linear inequalities in the variable of optimization. You already have learned linear inequalities and plotted them in your previous class, that is 11th. Now let us recall some key points. The linear function which is to be optimized subject to the given condition is called as objective function. The system of inequalities under which the optimization is to be accomplished are called as constraints. If you remember, you have written x plus y less than equal to 20 or 2x plus 3y greater than equal to 15. These are all nothing but the constraints. Now, the common region determined by all the constraint is called as the feasible region. Now, let us see which are the types of linear programming problems. First is manufacturing problem, then we have diet problem and transportation problem. So these are the three problems which we are going to solve to get the solution, practical solution. Now let us discuss the stepwise approach to solve this LPP. We need to formulate the given situation to get the constraints in the form of linear function. We are going to see some examples related to this, because in your earlier class you were directly given the constraints. Here from the word problem, first we are going to frame the constraints, form the constraints. Now we will draw the graph of corresponding linear equations to the linear inequalities. Now we will find the feasible region. Now what is feasible region? You know the region which is commonly obeying or following all the constraint givens. And we will find out the corner points of this feasible region. Now we will find the value of objective function, that is z is equals to ax plus by at the corner points, to find the maximum or minimum of the LPP, whatever is asked. Okay, the minimum cost or the maximum profit. So as per the question, we are going to find out the desired things. Now let us come across a diet problem. We'll just discuss it in short. Now here Reshma wishes to mix two types of food P and Q in such a way that the vitamin contents of mixture contains at least 8 unit of vitamin A and 11 unit of vitamin B. Now food P costs rupees 60 per kg and food Q costs rupees 80 per kg. Food P contains 3 unit per kg of vitamin A and 5 unit per kg of vitamin B, and what is Q containing? 4 unit per kg of vitamin A and 2 unit per kg of vitamin B. Now we are going to find the minimum cost of the mixture. What we are going to do in this case is, first of all, let P consist of x kg of food Q and y kg of food Q. Right? Now minimum, as the cost was given 60 rupees and 80 rupees, we have framed the objective solution, that is z is equals to 60x plus 80y. Now according to the question, these are the two constraints which we have got, and then of course if I talk about cost or the quantity to be added to make certain kind of a mixture, you know very well these two would be always the positive things. Now we are going to solve these inequalities there, and then we are going to get a feasible region. You could see here, this is the region, right? And these points are showing you the corners of the point. So these are the corner points, and finding out the corner points later on, we are going to find out the value of the objective function there. So here you can see that the double shaded region was the solution of our set, and the corner points, as I have notified just in the previous slide. Now we have substituted these points in the objective solution, that is z is equals to 60x plus 80y, and in this manner we got that minimum cost is at 160 rupees and the accepted values would be 2 and 1.5, because I cannot take that 8 by 3 and 0. I cannot have only one single thing. I need to mix P and Q. So because of this point won't be taken up. So my required solution is this. Now let us proceed with the next manufacturing problem. A factory makes tennis racket and cricket bats. A tennis racket takes 1.5 hours of machine time and 3 hours of craftsman time, and while the cricket bat takes 3 of machine and 1 of craftsman time. Now see what is the availability given, 42 hours and 24 hours. Now he is asking you that what is the number of rackets and bats which can be produced in the factory or manufactured, and then the next condition is that if the profit on racket is 20 and 10 on bat respectively, find the maximum profit. So in the same manner here also we are going to first of all frame the constraints as per the given condition in the question. These are the two inequalities which we are having there, right? And then we are going to plot those regions which you have already studied. Here again I cannot have number of bats and rackets negative, so obviously the constant would be x and y both are greater than 0. Solving these two equations and getting the corner points, again we have substituted the things here, and now I got the maxima when the points are 4 and 12. So maximum number which can be manufactured is 16, and I have 4 and 12 as the number of rackets and bats. Now second condition is profit on racket is 20 and bat is 10. So to get the maximum profit, again I am framing a constraint, that is P is equals to 20x plus 10y. So now substituting these values here, I got in this case the maximum profit which I can get is rupees 200. So we have discussed about the diet problem and the manufacturing problem. Let us see the next one. It is transportation problem. You could see two godowns A and B having a capacity of 150 quintal, and they are supplying to ration shops D, E, F. Okay, and the requirements of those shops are 60, 50, 40 quintal respectively. Now let us see the cost of transportation. The first thing is that from the word problem we have tabulated the things here. It is given in a tabular manner so that it becomes very easy. He is giving you the cost of transportation here from depot to the particular godown. Okay, now here you could see here we have said let godown A supplies X quintals of grain to ration shop D and Y to the ration shop E. So in this manner again we are maximizing the condition what we are having here, and then I have got the constraints as shown here, right? Similarly, I will get the points in this case, and then I will be finding my required feasible region and then maximum and minimum value for the things. You could see here I am getting minimum value of transportation as 510 when x is 10 and y is 50. So in this manner we are going to solve these equations and find out the solutions for some practical problems which are there. So this is actually a tool to find out the solution for practical problems in a very easy manner using the graph. So keep learning, children. Try to solve these equations, frame the constraints, draw the graph, and then find the solution. You need to practice to plot the feasible region, and thank you. Keep practicing.